Hello everyone, welcome back to my YouTube channel. If you are back or a recurring visitor, thank you so much for your support. In this tutorial, we are going to have a little bit of fun. We are going to program a robot, but we are going to program this robot virtually. If you are interested in programming robots and you actually want to put it on a machine, you can purchase one on Amazon. On Amazon, you want to look for something like an Adreno. This is a pretty good one. You can purchase this one and practice programming robots. But for this tutorial, we are going to use a virtual robot. So I'm assuming that you have your environment already set up. If you don't, I am using a software called ROBOTC. You can download it online. And once you get to this page, you will click on a new file. And once you click on a new file, you would get to a blank screen. For this tutorial, we are going to use the C programming language. As the software said, ROBOTC. So this software predominantly deals with the C programming language. When you are a programmer, if you are using Java, Python, C++, most of those programming language, the logic is almost the same. It's just syntax is just a little bit different. So once we get to this screen, the first thing we want to do is find a robot. Click on download to robot, and it's going to ask us to give the file a name. So move robot.c, and we click on save. Then our virtual environment will appear. If it's your first time opening this program, you want to click on robot, and then you go down to compiler target, and you click on virtual worlds. If you purchase your robot on Amazon, then you click on physical robot, which means you have the machine, you hook up the machine to your computer, and you download the code from your computer to the robot. But we're not doing this today. We are using a virtual robot, so we want to click on the virtual worlds. And from here, you want to pick your robot, and also you want to create an environment for your robot to move around. So the build option is where you choose your environment for the robot. So right here we have a start, and you want your robot to start at this position. So let's put our start to this corner, and we also want a stop, and let's put our stop right here. So basically our robot will start here and it will stop when it reach this mark. If we go back, we click on play. Let's click yes. Save this. When you click on play, you would get to this screen, and that's when you would choose your robot. There are different types of robots you can choose. You have square bot. The buggy bot is actually cool. You have mama bot, then you have claw bot as well. So let us just stick with clawbot. We're going to choose clawbot for this tutorial, and this is how your virtual world would look. If you press play, nothing would happen because we did not write any code to download to this robot. So let us write some code to move this robot to the stop sign. Now, when you are on this page, the first thing you want to do is you want to let the compiler know which robot to download your code to. So to do that, we have to declare a statement at the first line. So that statement have to be at line number 1. That should be your first statement inside of this IDE. So we're going to write pragma config, and inside the pragma config we are using the standard model, so we are going to declare that. And we also want to write the name of our robot. So the robot we're using is the clawbot. And remember, the name of the robot have to be inside of double quotes. So right there, the compiler knows that we are using the clawbot. If you're using the buggybot, then you put the buggybot in here. If you're using squarebot, you put the squarebot in there. We have declared which robot we are going to use. Now let's write a function. You can put whatever you want inside of the main task. I prefer using functions and call them inside of main. But just remember, like any other programming language, your code or your program will start from main. So whatever you do above main or task main, it will not run unless you put it inside of main. It's the same thing as if you're writing a C program inside of Visual Studio. Instead of using void main or int main, in ROBOTC it is task main, because you are giving the robot a task. So let's write a move function to move our robot. So we're gonna call it move. Let's call it move robot. And our function is not going to return anything, so it's going to be void. Now inside here, we are going to give one parameter, which is going to be the speed of the robot. And for that, we are going to use a byte, and we are going to call it moto. Let's call it moto speed. And you can use an integer, but I prefer using a byte. A byte is really small. A byte takes up less space in your program. You can use an int, you can use a float, whatever you want to use, but a byte is more suitable because we're not going to make a robot move faster than 127. A byte goes from the range from negative 128 to positive 127, and in computer programming, 4 bytes is equal to 1 int. So if you use an integer, you're basically reserving 4 bytes in your memory to move the robot. We are not going to make the robot that fast. Our speed is going to be under 127, so a byte is more suitable for that. So we have our function declared on top. Now inside of our curly braces, let us create a while loop. So the while loop is going to read the sensor value. Inside of the while loop, we have a sensor value function that's going to return the value of the sensor we declared inside of the parameters. In that case, we declared a sonar sensor, and the sonar sensor is just a sensor that brings back a value from the robot and the range of the object. So for example, this is our wall, or this is an object, and this is the robot. So when the robot is moving, so if the robot is moving, there is a sensor in the robot that would declare the object. So the object is the wall, and this is the robot. So what we want to do is we want our robot to move, and when it reaches about 30 meters from the wall, we want it to stop. That's what the sonar sensor would return. The sonar sensor just returns the range between the robot and the object. Let us declare the motor speed. So and we want our right motor. So we're gonna equal our right motor to the motor speed that we declared inside of our parameter. And we are going to do the same thing for the left motor as well. So we have our right motor and we have the left motor, and both of them is going to equal to the motor speed. So that's basically our move robot function. Inside of main, let us just declare a short, or you can use a byte. So and then we're going to call this normal speed, and we want the speed of the robot to be about 75. And then there is a function in ROBOTC, it's called wait 1 millisecond. So what that function will do is it will stop your robot for like a second. So we want our robot to wait, and then we're going to call our move robot function. So inside of the parameter, we are going to use our normal speed that we declared at line number 14. This is our code to move the robot. So let us compile and see if everything runs as it should. So once we compile, we have an error. Let us see what our error is. So inside, what is it saying? Missing parentheses, missing the closing one here, and we have two T's here. Let us compile again. Okay, this here, we have to change the speed, is actually capital S. Let's compile. Okay, so we got no errors. So now we're finished writing our code. What we want to do is download this code to our virtual robot. So once this open up, click on the refresh button, click on play. Our robot would wait, and then our robot would move until it reaches the stop sign. Let's move the stop sign over here so I can demonstrate when it reaches 30 meters from the wall what it would do. And let's go back to play. We're going to save the changes, and let's go back to the environment, refresh, and then go. Now if we keep looking, let us turn on our sensor and let's turn the angle so you can see once it reaches 30 meters it will stop. Let's go back and let's change this to let's give it about 90. Our robot should stop just a little bit farther away from the wall. So we refresh and press play. So our robot is moving. We have our sensor on, so you see the sensor is scanning, and once it reaches 90, this time it stopped a little bit farther away from the wall. Let us go a little bit farther into writing the code. Let us make the robot turn left when they have encountered any type of object or a wall. We're going to write a function, and this function will also be a void function. Let's call it turn robot left. And inside of this parameter, we are going to declare a float variable, and we're going to call this one turn degree. So let's declare our variable, and this one also is going to be a float. Okay, so we have our current gyro, and our current gyro now, it is going to equal to sonar value, which is a function, and our sensor value in here this time, we are going to use the gyro. So remember at line number 5 we used the sensor value function, and inside of that function we were returning the sonar sensor, which detects how far the robot is from an object. But on line number 14, instead of using the sonar sensor, this time we want to use the gyro. The gyro is a sensor that detects how fast the robot is turning and what position our robot is turning. So in this case, we want to turn our robot left. So we declared our sensor, so which is our current gyro. And after we do that, we also want a loop. And we are going to do the same thing as we did at line number 5. So we want to call our sensor function, sensor value function, and this time we are going to use the gyro, and we want to say while the gyro is greater than the current gyro speed, and we want to minus that from the absolute value, And then we want to take our turn degree, what we have declared in our function parameter for turn robot left. So at line number 12, you see we declared our turn degree variable right there. So we're going to use that turn degree or turn dig, and we want to times it by 10. And inside our while loop again, we want to set the motor speed this time. So we're going to use the set motor speed function. We want to use the left motor and -50. And we also want to set the right motor as well, the right motor speed. And we want to put that as a +50. Now that should be our function. So in here, let us call our function turn robot left. When you're doing a turn degree, is same thing as a circular motion. Let's use this circle as an example. So we want our robot to hit 90 degree. We're going left this time. So a robot, if we do 90, our robot will turn and stop here. If we do 180, our robot will turn and go around and stop here. If we do 270, our robot will turn left and go all the way around here. And if we do 360, our robot will make a full turn with the function we have created. So let's compile this function, and what is our error we are getting here? Forget syntax error. Let's compile again and download it to our robot. So we declared 90. So let's see how our robot moved 90 degrees from here. We're going to reset and let us run, play. So our robot will go and it will stop and turn left 90 degrees. So you see it turned 90 degree and stopped. Let us bring it a little bit closer. Let's change this to 30. So let's actually change our robot to 180. So we have a 180, and let's see how. So remember this circle right here. Let me see if I can bring it a little bit closer so you can, and download it to the robot. So we changed this from, remember here, we changed this from 90 to 180. So what our robot will do, should do this time, instead of just stopping, just turning and stop here, it will turn and it will go all the way around and stop. It should turn and face back this, face back the start sign. So let us press play. So our robot will go. Let's see it from a different angle. So it stops when it reaches 30 meters away from the object and turn, come back. So this is a 180 turn. Now let's do a 270. And this time our robot should turn, go all the way around and stop right at 90 point. If we're turning it left, if you were turning it right, it would go the opposite direction. So let's refresh and press play. Let us look at it from the above camera angle. So our robot should turn and stop facing this wall right here. So it would turn 90, 180 and stop. And if we do a full 360, let's download to the robot, refresh, press play. so it will make a full 360 degree. So turn all the way around. So there you see our robot is making a full 360 turn, just going around and around and around. So robotics is really cool. It's not difficult once you get a hang of it. It's okay. So this is just part 1 of the video. I will keep on uploading videos on robotics as well, and different programming language, different programming tutorials. So please like, subscribe to the channel. You would get more of these things. And once again, my name is Nikki. Thank you for watching. Enjoy.